Good evening, everybody. I hope everybody can hear me okay. Haven't streamed in a little while. Looks like we have a pretty good turnout tonight. We were really hoping to be able to host this meetup in person, but unfortunately we are not quite there yet. So in the hopefully not too distant future, we'll be hosting YYC.js at the Platform Calgary building. So we hope to see all of you there soon. If I haven't met you before, I'm Serene and I work at Pixel Tree. We work primarily in a Ruby and Rails and JavaScript stack. Our company is really passionate about mentorship and the growing of junior developers in the community. And so when we noticed that this group has been dormant for a few years, we wanted to see if we could help to reboot it as our local tech community continues to grow. And we are always looking for others to help with meetup organization, as well as speakers and other ways that if anybody wants to contribute, please reach out to myself or Carolina in the chat if this is something that you'd be interested in. I'll have Carolina do a little wave in the chat so that, and that's the person to reach out to. If you'd like to help, you're not really sure what you can do, please reach out as well. You can also find us in the YYC Dev Slack group or just send us a message on Meetup. I don't have a whole bunch to say because we don't have a whole bunch of things set up yet with our group. Hopefully next month we have something a bit more organized, but we are really glad to have Ian here to talk about the past, present, and future of JavaScript. Ian is Calgary's very own JavaScript celebrity. And he works as a principal software engineer at Neo Financial, where they're building digital banking products for Canadians. He's also the maintainer of Create React app and contributes to Node.js as part of the tooling working group. He also works on a number of other open source projects, mostly in the JavaScript and TypeScript ecosystems.
Hi.
So I will let you take it away. We are going to leave 15 minutes at the end for questions. So if you have questions, please post them in the chat and we'll get to them at the end. All yours.
Right. Thanks for the intro, Serene. I think that's the first time I've been referred to as a JavaScript celebrity. Not sure how I feel about that one, but we'll go with it. So yeah, as Serene mentioned, I'm here to talk about the past, present, and future of JavaScript. I realize that's a very lofty title, which I will try and do justice to. Before we get started, I should note that I'm specifically going to be talking about the JavaScript language and not other sort of developments in the larger JavaScript ecosystem, like new frameworks, tools, things like that. Notably TypeScript, something that I won't really be discussing. That's maybe a topic for another future presentation. So Serene already did, most of the intro for me. So I'll just quickly go over this again. My name's Ian Sutherland. You can find me on Twitter or GitHub at IanSu. As Serene mentioned, I am one of the maintainers of Create React app. I'm a member of the Node.js team on the tooling working group. I am also an engineering lead and the DX team lead at Neo. And I should mention that we are definitely hiring at Neo. We're hiring in general, but also for the DX team and the engineering team, really all teams, product, engineering, marketing, customer experience, partnerships. We have many open positions here in Calgary. So if you want to write JavaScript or more specifically TypeScript, then you should absolutely get in touch. You can get in touch with me, or we have a new site, neofinancial.careers, where you can find all of our open positions. We've also been doing regular virtual open houses where you can come chat with people from the engineering and product and other teams. Get to know a little bit about Neo and about the people there. And you can find all that information on neofinancial.careers. So before we get started here, I'm just going to I'll tell you a little bit about my sort of like JavaScript background. I think it's probably pretty similar to a lot of other people's. So I've been a software developer for a long time. I don't really want to say how long, it makes me feel old. But long ago when I was making static web pages and things like that, or dynamic server-side web pages, I dabbled in JavaScript a little bit. And then jQuery came along and sort of kickstarted that whole era of JavaScript development. And so I got more involved in JavaScript at that point, and even started working with some of the other JavaScript frameworks of that era, things like Backbone. And then along with those sorts of things came tools like Gulp and Grunt, which is kind of what gave me my introduction into Node.js. And then I started using Node more and more after that. I built some development and testing tools with it in my job at the time. And then around 2016, I was pretty much a full-time JavaScript developer by that point. And I've been doing that ever since. So yeah, let's get started here. So maybe we'll start with a recap. So the last, I had to look this up, the last YYC.js was June 21st, 2016. So that was more than 5 years ago. And it turns out quite a lot has happened in JavaScript in that time, which is maybe a little bit unusual. You could probably ask what's happened in the last 5 years in language X or Y, and in a lot of cases the answer would probably be nothing or very little. But JavaScript, especially in the last 5 years, has really established like a pretty rapid cadence of releases. And interestingly, this trend seems to be spreading to other languages. For example, Java has been doing a lot more rapid releasing in recent years. So personally, I think that's a great thing to see. So we'll just, like I said, we'll do a little recap here. So we'll start with ES 2015, also known as ES6. I'm going to use the year-based version numbers here, just because I find it a little bit less confusing. So ES 2015 was released in June of 2015, so about a year before that last meetup. And this was a huge release with some really significant features that really kind of transformed JavaScript development. It was the first major improvement to the language since ES5, which came out in 2009. And so ES 2015 brought us things like promises, classes, arrow functions, let and const, rest and spread operators, iterators and for of loops, generators. I mean, there's some real bangers in there. And in fact, there's so many that I actually needed a second list. So other features include like template strings, object and array destructuring, the map, set, weak map, and weak set objects, proxies, symbols, default values for function arguments, Unicode support. I mean, the hits just keep coming. This was a really, really big release in the history of JavaScript. And it's actually, it's sometimes easy to forget that these features have transformed, things like promises have transformed JavaScript development to the point like they're basically ubiquitous these days. And it's sometimes easy to forget that these features are only about 6 years old. And so following up on ES 2015, we're just going to do a quick kind of run through of what's happened since then. So we followed that up with ES 2016, which was released 1 year later in June of 2016. And compared to the huge release that was ES 2015, this one was a little bit smaller. It only included 2 features, the array.includes method, which is a pretty useful method. I use that one pretty regularly. And the exponentiation operator, which I don't think I've ever used. I guess one of the more significant things with this release, though, was that it was the start of the new annual release process of the JavaScript specification. And so moving on, we have ES 2017. Also, a relatively small release, but had a couple notable features, not the least of which is Async Await. Much like promises, Async Await really transformed the way that we write JavaScript code. Some other features, shared memory, like shared array buffers, and atomics, which are methods for accessing shared memory in a thread-safe way. We also got the object.values and object.entries methods, the string.padStart and string.padEnd methods, and support for trailing commas in function arguments. And then moving on, we had ES 2018, Async Iterators is something we got, as well as REST and spread for objects. You might not remember, but when REST and spread were initially introduced, they only applied to arrays. And pretty much right away, people were like, hey, this would be super useful for objects. And so it took a couple of years, but that eventually got added to the spec. I personally use REST and spread probably 10 times as much with objects as I do with arrays. We also got some regular expression improvements in this release, name capture groups, look behind, .all flag, and finally the promise.finally method for cleaning up in your promises. ES 2019, just a couple features in this one, array.flat and array.flatMap, as well as trim start and trim end string methods. And finally, the optional catch binding is kind of a nice, convenient feature. Previously, if you're in a try-catch block, you have to include the error argument in the catch portion, whether you use that or not. Now you don't have to do that anymore. Makes linting and things like that a little bit easier. Okay, then we got ES 2020. This was another pretty big release. There's definitely some popular features in here. Probably the most popular is optional chaining, along with nullish coalescing. We got the promise.allSettled method, string.matchAll, big int, which is a new primitive data type that supports arbitrarily sized integers and all the various operations you might want to do on those. We got the global this object, which depending on your environment, if you're in a browser environment, global.this is the equivalent of window. Kind of just makes it, instead of detecting like, does window exist, does it not exist, you can just always refer to global this. We also got for dynamic imports, import meta, and the export star syntax. And then finally on our recap, we've got ES 2021, which was released this June. So this is kind of the current state of things. That included promise.any method, string.replaceAll. In ES 2020, we got matchAll, now we have replaceAll. That also gave us weak refs, which previously we got some form of that in the weak map and weak set objects. Now you can define any variable as a weak reference to something, and that just means it won't prevent garbage collection from happening. We also got the new logical assignment operators and the numeric separator support, which that one was really great. That's been in TypeScript for 3 or 4 years, I think. And so very nice to finally have that in JavaScript. And so that kind of brings us up to today. This is everything that's happened in the last 5 or 6 years in JavaScript. So next, I just want to talk a little bit about the evolution of the JavaScript language. Like who gets to decide what goes into all of these different ES versions, and what does ES even mean? Well, ES stands for Ecmascript, and so Ecmascript is the specification of the JavaScript programming language. It's maintained by ECMA International, which is the European Computer Manufacturers Association. Fun fact there. And ECMA 262 is the specific ECMA specification for Ecmascript. And that specification is overseen by the Technical Committee 39, also known as the TC39. So they're sort of the governing body of that specification. And so the TC39 meets approximately 6 times a year to discuss and vote on various language proposals, which we're going to get into in a minute here. And it's largely made up of industry professionals, usually from bigger companies that have some stake in the JavaScript language. So that would be companies that make browsers or involved in Node.js or other projects like that. So think like Google, Microsoft, IBM, those kinds of companies. There are some representatives from smaller companies as well. But yeah, those are kind of the big ones. Just a quick little aside here. There's also another standards body that contributes some things adjacent to JavaScript. That's called the WG, which is part of the W3C, the World Wide Web Consortium. And so they are actually responsible for web platform specifications. So there's a slight difference there. So the TC39 and ECMA, they're responsible for the language specification of JavaScript. And so as an example, something like optional chaining, that is a language level feature of JavaScript. Whereas something like the fetch API or web workers or things like that, they have an implementation in JavaScript, but they're actually web platform features. So that's why, for example, all of those things were left out of my previous recap. Okay, so let's move on. So yeah, what exactly is an Ecmascript proposal? So they're proposals for new language features, and proposals are submitted and worked on in the open at this GitHub repo that I've linked here, tc39/proposals. And so you can go there and you can see all of the current proposals, and each proposal will indicate what stage it's at. So there's a 5-stage process that something goes through on the road to becoming a part of the Ecmascript specification. And so just quickly cover what those are. So stage 0 is really just an idea and can be submitted by anyone. Excuse me. There's no criteria to submit a stage 0 proposal. You can go to that GitHub repo above and open a PR and type out your idea for a feature and submit it. And that's basically a stage 0 proposal. After that, to move to stage 1, a proposal you need one or more champions, which is someone that's on the TC39 to sort of agree to bring your proposal forward. And you also need to provide kind of like a rough proposal, which would include things like high-level API documentation, some usage examples showing, maybe here's what the current way to achieve this is, here's what the new syntax would look like, something like that. And you have to, in order to advance to each of these stages, this is something that when the committee meets, all the proposals are presented and then they vote on whether or not a proposal is going to move to the next stage. And so stage 2 is the proposal is written out using the formal spec language, which we'll talk about in a second, not in too much detail, don't worry. Stage 3 means the spec text has been approved and the feature, the proposed spec has been implemented in at least one JavaScript engine. Little side note about TypeScript here. TypeScript is considered to be a JavaScript implementation, and TypeScript will implement all stage 3 proposals or sometimes earlier. Like I mentioned earlier, the numeric separator proposal, that one they implemented like a few years ago. But at the very latest, they will implement all stage 3 proposals. And so they count as, when it says being implemented in at least one engine, a TypeScript implementation counts. And then finally, to get to stage 4, I guess I should mention too that in stage 2 and 3, you can kind of go back and forth there a little bit. The spec is written and the features implemented in one JavaScript engine, and depending how that goes, it might kind of go back to the drafting stage, and the proposal, the spec will be updated, and then the implementation will be tried again. So you can kind of sit in those stages for a while until any issues are worked out, and then finally the proposal goes to stage 4, and so that means the spec is completed. You've got your at least one implementation, and it's ready to be included in the Ecmascript standard. And so stage 4 basically means like done. This is shipping, and so those are the things. When we talk ES 2021, what features are in there? Those are the features that have reached stage 4 during that year. Okay, so one last note here. I did say I would tell you what the formal spec language looks like. So this is an example of the formal spec language. It's kind of dense and difficult to read. It's a very formal definition of basically everything. Like here we're defining what an async function expression looks like. It's if you ever have insomnia and you need some before bed reading, I recommend reading through the spec. Another note about this, Google actually wrote a programming language that looks an awful lot like this spec, just so that they could implement the spec very easily. You can almost copy these definitions from the spec into their language, which is called Torque, and that's how they implement a lot of these things in V8. Okay, so now that we know how this whole process works, and I mentioned all of the proposals are out in the public in that TC39 proposals repo, let's take a look at what some of them are. So there's a whole bunch of proposals in there, all at various stages, and you can expect those to be coming to JavaScript in the near future. So yeah, let's take a look. We'll start with some stage 3 proposals. So probably the biggest stage 3 proposal that's out there right now is the Temporal Api. This one should be coming soon, although there are a couple of small blockers, which I will talk about shortly. So if you're not familiar with the Temporal API, it's essentially an entirely new date-time API for JavaScript. If you've worked with JavaScript's current date API, you probably know that it's not great, which is probably pretty generous. Usually you might use it to create a date from a string or convert a date to a string, and that's probably it. If you're doing anything else with dates in JavaScript, you're probably using a library like date functions or maybe moment or something like that. And so the Temporal API is an attempt at bringing a much richer date-time API to JavaScript that supports a lot of the features that you would find in those other third-party libraries. So some of the notable features here, there are now multiple types, multiple data types for dates, times, date times, and durations. So The current date API basically just gives you a date time. So we've got a whole bunch of new types available here. Timestamps are now specified in nanoseconds from the epoch instead of milliseconds. So that can give you much more precise timings. Another huge feature with the Temporal API is that it has built-in time zone support. Also, all the objects created with the Temporal API are immutable. And last but not least, months are no longer zero indexed. For some reason in JavaScript, the days of the month are numbered like 1 through 28 or 30 or whatever. And the months are numbered 0 through 11. I don't know whose idea that was, but it's a huge pain. And that is now gone in the Temporal API. So we're going to take a look at some code examples here and see what this API looks like. So I should note a lot of these examples came from an article by Axel Rauschmeier. He wrote a really great article about the new Temporal API. I do have a list of links from this talk that I'll be sharing later. And that article is included in there. So I definitely recommend checking it out. So yeah, to start with here, we'll look at the temporal.now, which is very similar to the date.now method. So in the first example, we've got temporal.now.instant. An instant just means a moment of time as specified in UTC. So we could probably write that one as temporal.now.zone date time and then use UTC as the zone. But shorter way to do that is just to use instant. So you can see that gives us basically what we're used to seeing from the current API. It's a ISO 8601 date string. And then, the next example there, we're creating a zoned date time, and we're specifying Asia, Shanghai as the time zone. So you can see here, we end up with something that looks an awful lot like an ISO date string, except it's got that Asia, Shanghai, the time zone information in square brackets at the end of the string. So I mentioned that there are a couple of holdups with this API, and this is one of them. So specifying time zone or even the calendar, the Temporal API lets you use multiple different calendars if you want. And that is not supported in ISO 8601. So a proposal has been made to the IETF to add support for time zones and calendars in those date strings, but the Temporal API is not going to ship until that proposal gets accepted. Okay, moving on, we can do something called a plain object, like in this case, a plain date time. So you can see that's a date time string with no time zone. And then below that, we have just a plain date. So this is something you can't really do with the current JavaScript API. If you don't care about the time, you only want to represent a date, you can do that now. And then there's the plain time one below that. If all you want to represent is a time, you can do that, and that's a different data type. So moving on, here's a couple more examples with zoned date times. So here we're creating an epoch, like a number of nanoseconds from the epoch. Interesting thing to note here is you can see the letter N at the end of that number. That's actually a big int. So this API is building on top of some of the previous enhancements in JavaScript. And then below that, we're specifying our time zone, which is America, Los Angeles. And then we're going to call temporal.zoneDateTime. We're passing in that timestamp in nanoseconds. You do have the option to, you don't have to specify it in nanoseconds, but in this case we are. And then that's going to give us the time string that you can see below there. A couple other interesting things with the Temporal API. There's this series of from methods, which let you construct a temporal object from something else. So in this case, we're constructing a new temporal object, a new zone date time object from the previous one. So the value of zone date time 2 here is going to be exactly the same as the one above, but it's a clone of that object. It is a separate object. And a couple more examples here. This looks a lot like the current JavaScript API for this. You can say new date, and you can specify the year, month, day, hour, minute, second. A couple differences here. In the new date API, those are all just positional arguments, which can be a bit confusing or hard to read. Here, you're passing an object with named parameters or properties. So easier to read, and also you can omit some of these properties as well. Another thing to note is the time zone there. That's definitely not something you can do with the current API. And so that's going to give you exactly the same date string that we had in the previous example. And then finally, in the last example here, we can also create a zone date time object from the string representation that we previously got. Okay, moving on. So this is another, I think, really exciting new data type that this API introduces, and that is the concept of a duration. So this is something that we don't have at all in the current API. So in this first example here, we're saying we want to create a duration. Again, we're using that from method. And so we're saying our duration is going to be 1 year, 2 months, 3 weeks, 4 days. And then if you look at the string representation below that, all string versions of these durations start with the letter P. I don't exactly know why. I think it stands for period or something. And so we have P, and then it says 1Y, so 1 year, 2M, that's 2 months, 3W, 3 weeks, 4D, 4 days. So that's the string representation of that duration. And then below example, we're doing a time duration, so 1 hour, 2 minutes, 3 seconds, and 4 milliseconds. So once again, the duration string starts with the letter P. And then we have a T to indicate it's the time portion. And then you can see we've got 1 hour, 2 minutes, and 3.004 seconds. The third example here, we're kind of mixing the two. So we're saying 30 days and 50 hours. So that's represented as P30. So the string starts with P, then we have 30D, then we have the letter T to indicate the time portion, and 50H to indicate the hours. You can also have a empty duration. In this case, we're saying hour 0, and that's represented as just PT0S. Some other interesting things you can do with durations. So here we're constructing a duration up top. That's 3 hours and 45 minutes. There's this total method on duration, and you can pass a unit to that. So in the first example, we're saying, show me this duration in seconds. And so we get 13,500 seconds. In the second example here, we're saying, give me the duration in minutes. So we get 225 minutes. So some useful methods there for working with durations. And actually, we can go even further here and start doing some actual date math with the Temporal API. So in this first example here, we're saying our source time is a zoned date time in the America-Chicago time zone. And then down below, we're creating a target zoned date time. And we take the source zone date time and say source.with time zone and just set a different time zone, in this case, America Anchorage. And that will give us a new zone date time object where we've converted the time from the America Chicago time zone to the America Anchorage time zone. So you can see in the America Chicago case, it's January 9th, 2 a.m. And in the Anchorage case, it's January 8th at 11 p.m. Some other things we can do. Here we've got a flight departure time in the Europe Berlin time zone. And then we've got an arrival time in the America Los Angeles time zone. We can call departure.until and pass the arrival, and that will give us a duration, which is the amount of time between those two zoned date times, even though they're in different time zones. And so it looks like that's 13 hours and 15 minutes difference. And then kind of similar to what you might see with some date libraries, you can also just, in this case, we're creating a plain date, which is just March 8th, 2022. And then we can just call the add method on that and say we want to add one day to that. And that's going to give us March 9th. So some nice utilities there for doing time math, which is always a challenging thing to do. And then lastly, I just wanted to show quickly how the new Temporal API can integrate and interact with the legacy date API. So in the first example here, we are creating a legacy date with a new date of 1970, January 1st. If we want to convert that to a temporal object, there's a new method, toTemporalInstant. And so that will just give you a new temporal object that represents that same moment in time. You can also do this with timestamp. So in this case, we say temporal.instant from epoch milliseconds and pass in that timestamp, gives us the same result. And then, of course, you can also create a temporal object from a regular ISO 8601 date string. Okay, and so that's it for the Temporal API. This is, like I said, probably the most significant API change that's coming to JavaScript. I'm certainly looking forward to this. The current datetime capabilities leave a lot to be desired. Hopefully that process of getting the ISO 8601 spec updated to support time zones doesn't take too long. And I think once that's done, we'll be seeing this feature very shortly. So, okay, moving on to some of the smaller stage 3 proposals. I actually just learned about this one while I was researching this talk. It's called error cause. So basically it allows you to catch an error and rethrow it with additional context. The original error can be assigned to the clause property of a new error. So let's see an example here. This is maybe what you might do now. So you've got a try catch. You catch your error, and then maybe you throw the error. You throw a new error. You include an error message of your own, hopefully something more useful than something went wrong. And then you also want to include the original error message from the error that you captured. And so this kind of works. The problem here is you're losing a lot of information. For example, you're losing the stack trace from the original error. And the stack trace that your new error is going to have is going to start on the line where you construct the new error, which is probably not what you want. So let's take a look here what we can do with this new functionality. So the first thing we're going to do, we catch the error, and then we're going to create a new error with our super useful error message. And then we're calling that wrapped error. And then we're going to set wrapped error.cause to the original error. And then we're going to rethrow, or then we're going to throw wrapped error. So that means later on when we catch that, we'll have all of the context from the new error we constructed here, as well as the entire original error. And you could wrap, many levels of errors using this. Now, one thing to note here is a little bit more verbose than what we had here, the previous syntax. But you can kind of work around that by doing something like this, where you create a custom error object that extends error, and then the constructor of your custom object takes a message, which is a string, and then a cause, which is just going to be the other error object. And then so you can see down below, we catch that error, and we're able to just throw a new custom error with our message as the first argument and the original error as the second argument. Okay, up next we have relative indexing. So this one's a bit of a kind of a no-brainer one. The idea here is to simplify indexing objects like arrays and strings, specifically from the end. A lot of other languages let you, like Python, let you specify negative array offsets, which JavaScript doesn't. So this proposal adds an at method, which will get you an element at that position. The key thing here, though, is that it accepts both positive and negative offsets. So just a really quick example here. This is kind of what you would do right now. So we've got an array of 4 numbers. In the first example here, we just use, so let's say we want to get the second last element. So in the first example here, we're using numbers, and then the numbers.length -2, so that to give us the position. It's kind of awkward. Slightly less awkward syntax. You can use numbers.slice -2, and then slice returns another array. So you only want the first element in that array. So maybe a little bit better syntax. The downside there is it actually creates a new array from whatever your offset to slice is all the way to the end. So maybe not the most memory efficient there. And so here's what that looks like with the new syntax. You just say numbers.at -2, and that will give you the second last element. So nice enhancement there. Kind of similar, there's a new array find from last proposal. It's also stage 3. This just lets you search for an array element or index starting from the end of the array. And so it adds 2 new methods, array.findLast and array.findLastIndex. And we can see an example here. This is what you would maybe do now. Again, we've got our array of 4 numbers. Option 1 is just use a regular find and start at the beginning of the array, even if you know that your element is going to be at the end or near the end. So it's possibly just inefficient. And then the second option here is you can reverse the array first and then find your element. But reverse is actually going to mutate the array, so that's maybe not great. And so with this new proposal, that would just look something like this. And so these work exactly like the find and find index methods. They just start at the end. Okay, so moving on to stage 2. This is where things start to get more uncertain. There's a lot more churn in proposals in earlier stages. So the first stage 2 proposal I want to look at is the records and tuples proposal. And so this is kind of an interesting one. It adds 2 new deeply immutable data structures called record and tuple. So a record is basically, you can think of it like an object, specified almost the same as an object with the curly brackets. The difference being the number symbol or hash or octthorpe at the beginning. And then a tuple is basically an array-like structure. So again, it's very similar syntax to an array where you just specify the elements by position inside square brackets. Something interesting about records and tuples, they can only contain primitive types and other records and tuples. So things like objects are not allowed. And let's take a look at some examples here. These examples I just took directly from the spec. So in this case, we're creating a record called proposal. You can see we're giving it a few, we've got a number and a string here. And then we've actually included keywords is actually a tuple. Because you are allowed to include records and tuples in other records and tuples, just not objects and things like that. And then this works just like you would access a regular object. So proposal.title gives you the title property. Proposal.keywords1 gives you the second keyword in that tuple. We've got a couple more examples here. You can use spread just like you can with objects. So here we're creating a new proposal from the previous proposal and just overwriting the title property, which you can see down below when we print out proposal2.title. That's been changed. And also all of the object functions like object.keys, object.includes, object.entries, object.values, they all also work on records. And then moving on to tuples, very similar. So here you can see we've got a for tuple. We can print out some of the elements there, which you do just using the regular square bracket indexing like you do with an array. You can also slice and spread tuples just like you can with an array. So basically in this example, we're taking the first three elements from the tuple above and replacing the fourth element at error message with -1. And you can achieve the same thing. There's a with method. So here we're just saying replace element 3 with -1, does the same thing. And you can use any of the methods you would use on an array, like map or for of or find or things like that. Those all also work the same on tuples. Okay, we've got just a few more here to talk about. This one's probably going to be pretty handy. New set methods. So yeah, let's just add some convenience methods to the set object for doing things like union and intersection, as well as some functions for comparing sets. So we have combination methods like set.intersection, set.union, set.difference, set.symmetric difference. An interesting thing I noticed in reading this, it looks like the argument that you're passing there doesn't actually have to be a set specifically, it just has to be iterable. And then, yeah, there's a couple comparison methods. We can see if a set is a subset of or a superset of or disjoint from whatever it is we're passing in. So I'm not going to show examples, code examples of these. I think it's kind of straightforward from the method signatures here. Another stage 2 proposal, change array by copy. So this adds new non-mutating versions of existing array methods. So I mentioned earlier, if we call reverse on that array, that actually mutates the array. Mutation generally considered bad these days. You know, immutability is what it's all about. And so this just adds some array methods that they basically give you a new array. So instead of calling, array.reverse and mutating that array in place, you would say, like const new array equals array.withReversed. There's a few other ones, with sorted. So you can sort an array and generate a new version of it. With spliced, with at. I'm not 100% sure what that one means. The at operator is still new, and I don't think it mutates. So I guess this would let you mutate an element at that index and give you a new array rather than just overwriting that index. Okay, now we're getting into stage 1, where things are really, really uncertain. So one of the proposals there, and by the way, there are a lot of other proposals especially in the earlier stages, stage 0, 1, 2. So I only included a few here that I personally think are interesting. So a stage 1 proposal that I'm interested in, possibly because I write JavaScript at a financial company, is the decimal or big decimal proposal. So the idea here is that we would add a new data type for representing decimal numbers. JavaScript currently has no support for decimal numbers. So it's still pretty early stages on this proposal. There's a bit of debate between whether it should be implemented as big decimal or decimal 128. The difference being decimal 128 is 128-bit representation. So there's a maximum size number you can represent there, whereas big decimal, much like big int, is arbitrary precision and size. The discussion seems to be heading in the direction of big decimal, but this is kind of still up in the air. And then another stage 1 proposal is the operator overloading proposal. This one's kind of interesting. Other languages like C have this. I think Java does too. I'm not sure. Basically, this allows you to specify the behavior when applying mathematical operators to your own custom objects. So you can specify, what happens when you use a plus sign to add those objects together, or minus, or multiply, or divide, or compare. And the interesting thing about the operator overloading proposal is that it would actually allow you to implement a lot of these other data types, like decimal. In addition to that, you could build, a vector type, a matrix type. So there's a bit of debate about whether operator overloading should happen first, and then decimal or big decimal will be built on top of that, or if we just go ahead with the decimal proposal instead. Something that's a little bit up in the air as well with this is the behavior of the triple equals operator. So, normally if you have we're talking about comparing two objects here, and normally if you compare two different objects, they're always going to be different. However, if we consider the decimal use case, if you have a decimal object, say its value is 1.5, and you have another decimal object and its value is 1.5, and you use triple equals to compare them, you would probably expect them to be equal, which would not be the case currently. So there's a bit of debate about how that would be handled when implementing this kind of a feature. And there's a few, like I said, a few other proposals at this stage that I won't get into, like pattern matching and observables. And in stage 2, there's a few like decorators that I didn't get into, or the pipeline operator. But if you're interested in any of those things, you can read all about them at that TC39 proposals repo. And that's pretty much all I've got. Wanted to kind of take you through, how we got to where we are today, and then just give you a little bit of a look at what might be coming next in ES 2022 or 2023. I mentioned I would provide some links, so there's a URL there. I made a gist of a few different links that I use when putting this together. Maybe someone could put that into the chat, if possible. Just leave that up for a second. And then finally, another link here. This is how you can get in touch with me if you like. If you want to talk about JavaScript or TypeScript or React or Node.js, by all means, send me a message on Twitter. Also, if you're interested in possibly applying at Neo, you can also get in touch with me, or visit that neofinancial.careers site that I mentioned. And that's all. Thank you everyone for coming. And I'm very, very happy that I got to be here and sort of kick off this new era of YYC.js.
Awesome. Thanks, Ian. That was great. Do you say Babel or Babel?
I say Babel.
I also say Babel, but I've heard other people say Babel recently, so I wanted to see what you thought. James in the chat asked if Babel supports this as a shim. I think he was talking about the Temporal API.
I believe there is a polyfill or shim for temporal. Yeah.
Interesting.
I saw a note earlier about like don't use it, but as with most of those things, there are like polyfills or shims for a lot of these experimental features. You generally don't want to use them in production, especially if they're very early stage proposals, because they can change a lot. The decorators proposal that I mentioned at stage 2 is a great example of that. That proposal's been in the works for like 4 years or something, and there's been a lot of churn there. There were 2 competing specifications, and I think they might have even just ended up going with the 3rd one. So beware if you're trying to adopt features that are before stage 3.
Yeah, I think it'd be neat to just pull it and play with it and see what it's like.
That part's definitely fun. Just don't ship.
Someone else had asked if the Temporal API does date formatting.
That is a good question. As far as I know, it doesn't. But I could be wrong. It's a very large API. I mentioned the article that I kind of used when I was putting this together, which is included in the links there. I definitely recommend reading that if you're looking for more information. And even that is pretty in-depth, but I don't think it covers everything. So probably worth looking for yourself.
Yeah, I found it quite interesting because I think, like you mentioned, a lot of this functionality already is in a bunch of other languages. I mean, it being a web-based language, it's going to be a little bit harder to implement these things. But do you have a sense of what their goal is? Are they trying to make the language easier to use, like a bit more developer-friendly, or so that's kind of the sense I'm getting?
Yeah, for sure. I think a lot of these things are done for the purpose of making the language more developer friendly, and also just kind of bringing it to a similar level as maybe more established languages like Java or I don't know, C++ or something, or other sort of popular languages. They're trying to make JavaScript. I mean, it already is a fully featured language, but they don't want there to be anything, I think, that's sort of lacking from it.
Because you can do everything you need to, but I think some of these new features would just make it a little prettier, a little more elegant.
It's not always the easiest to do certain things, or you end up relying on a third-party library or something like that. Like that's another thing I think that factors into this. If there's the temporal API like borrows a lot of stuff from libraries like moment and date functions and stuff like that. So they're definitely looking and seeing like these are the things that people want and are using. Those libraries are enormously popular, and then bringing those things into the language, that's pretty similar to what we do, for example, with the tooling working group in Node.js. We're kind of doing the same thing. Like what are the packages? What are the NPM packages that get 100 million downloads a week that people are using in every Node project? And then looking at those and seeing, does it make sense? Like, should we be offering that ourselves?
Yeah, I know definitely when we spin up a new JavaScript application, there are a few libraries that we just always need, right? I mean, we can hold off, but eventually we'll need date functions.
Right.
I mean, we used to always use moment back in jQuery times.
Right. Not quite as recommended these days.
Yeah, it's pretty bulky, but definitely with all the additions of the NPM packages, it'd be nice if JavaScript just supported them natively. So.
Well, like I said, that's kind of the, some packages end up with like JavaScript language level support. Some other functionality ends up as part of the web platform. And then in Node specifically, packages will get pulled into core in some cases. So that there is definitely a as sort of an overall trend of identifying the missing pieces, the most popular missing pieces, and pulling them in where it makes sense.
Yeah, that's cool. All right, I think that is our time. I think we're gonna end on time this week or this month, so that's great. We had a really good turnout. Lots of thanks in the chat there for you. If you guys have any more questions for Ian, reach out to him on Twitter. I can attest to he replies to DMs pretty quickly, so definitely reach out to him there. And thanks, Ian, for being our first speaker for the reincarnation of YYC.js, and I hope to see everybody again soon. Bye, everyone.
Thanks so much.